particle is projected at 30 meters per second at an angle of 50 degrees to the horizontal. After travelling for 4 seconds, it just clears a wall. Taking g is 9.81 meters per second squared, find the height of the wall and the direction of the motion as it passes over the wall. So if we just get ourselves a diagram, so the particle is projected like so. So this is 30. The angle here is 50, and it goes through this parabolic path, and at some stage it passes over a wall here, and we know when it gets to here the time is 4. Now there's certain things you have to do in these questions before you proceed, and resolving the components of the initial velocity is one of them. So in this direction we're going to have 30 cos 50, of course cos because it's the adjacent, and this one up here is going to be 30 sine 50. Now if we consider first of all that the acceleration is due to gravity, is 9.81. Then think about the vertical displacement. So here we're going to use s equals ut plus a half at squared. Then let's call it y, the displacement. That's going to be 30 sine 50 degrees t plus a half of negative 9.81 t squared. But we know t here, we know t is 4. So we're just going to substitute that in. We've got 30 sine 50 degrees times 4. Take away a half times 9.81 times 4 squared. So we've got 30 times sine 50 times 4. Take away 0.5 times 9.81 times 16 gives me 13.4 meters. Correct to 1 decimal place. Now in part B we want the direction of motion as it passes over the wall. So if that's our particle, we know it's going to have a horizontal component, and because there's no acceleration horizontally, that's going to be 30 cos 50, and the vertical component will be downwards. Now if we use v equals u plus at, then vy is going to be 30 sine 50, take away 9.81 times 4. So the x velocity we know is 30 cos 50, and vy is going to be 30 times sine 50, take away 9.81 times 4, which is negative 16, I think it was 0.26, let's just check on that, meters per second. Now we can use that to get the direction of motion. So we know that it is going across 30 cos 50 and downwards 16.26, and then we can work out this angle. We've got a right angle triangle here. So theta is going to be the inverse tangent of 16.26 divided by 30 cos 50 degrees. So we got the inverse tan, and then we've got the last answer. Divide that by 30 times cos 50. And that gives us 40.1 degrees. So we can say it's 40.1 degrees below the horizontal.